Okay, today we're going to review some of the stuff we went over yesterday on quadratics. We're going to review the parts of a parabola, how to find the vertex from an equation. And then I gave you a paper yesterday about evaluating a quadratic given some kind of value, okay? They'll give you something to plug in for x. So let's start with the parts of a parabola. Let's get some chalk you can see. We know that a quadratic, if graphed, makes this picture, which is called a parabola, okay? This is a parabola. The parts of a parabola are going to be the main one, the first one we're going to talk about is the vertex. And we found out that whether the parabola points up or down, the vertex is where the direction changes, right here, the vertex. Now, in each case, the vertex is called either a maximum or a minimum, depending on the position that it's in. The vertex here is at the bottom. It's the very smallest point on the graph. And so this is a minimum. They refer to it as a min sometimes. And the highest point when the parabola is upside down is called a maximum. Sometimes referred to as the max. Find the max. Now the other parts are what we're going to deal with today, and we'll go ahead and talk about those. If we have a parabola that looks something like this, then of course, here's the vertex. Can y'all see that? Okay. Can you on the remote, can you see it okay?
Yes, ma'am.
All right. Since this is the x-axis, then this point and this point are called the x-intercepts. It's right on the axis. These are x-intercepts, the points that are on the x-axis. And the same is true on the y-axis. We have a point on the y-axis where the picture comes across, cuts across, and it's called a y-intercept. And today we're going to find out how to find the value of those out of an equation. Now with a parabola, we found out whether the parabola goes up or whether the parabola goes down. You're going to have one y-intercept all the time. You're going to have one. Now we found out yesterday that you can have two x-intercepts, which is the most popular, or one x-intercept, which would be if the parabola came and just touched the x-axis once. There's one x-intercept, or it's very possible to have no x-intercepts, where the parabola never comes close to the x-axis. So intercepts, you can have two, one, or no x-intercepts. For an up or down parabola, you're only going to have only one. Only one y-intercept. Okay? These are the parts that we're going to talk about right now. Tell me if you need a little bit of time to write it down or take a picture. You're okay?
Yes.
Almost there?
What is that? 0 squared down at the x-intercepts?
The x-intercepts, you can have 2, which is the most popular, or you can have only 1, or you might have no x-intercepts.
Okay.
Okay, but the y-intercept, you're only going to have 1.
All right. I got it.
All right. Now the next was how to find the vertex. Now it's real easy to find the vertex if this is on a graph. You just have to find out what the coordinates of that point are, the x and the y. However, you're not always going to have a graph. Sometimes you'll just have the equation, the quadratic. So we're going to find out how to evaluate the vertex, okay? Okay, so an example here would be, let's say, f of x equals negative 4x squared plus 6x plus 18. Okay, and the instructions say find the max or the min, the max or the minimum value of this parabola. Okay, the first thing we know is as we look through here, the largest exponent is a 2. That's the definition of a quadratic. And since it's a quadratic, it is going to make the graph of a parabola. Okay? Now, one thing that I pointed out yesterday, I don't know if you caught it, but if there's a negative on the leading coefficient, that means the number with the x squared. If there is a negative, that means it's going to be an upside down parabola. If this is a positive, it's going to be a right side up parabola. Okay? So we know that this one is going to look like this, okay? Because of the negative that's in front. So when it says find the max or the min, what are we finding? What is this point? Is it a max or a min?
The max.
It's a max, right? You're going to find it the same. You're going to find it the same way. Okay, remember that this max is the vertex. So we've got a formula to find the vertex of a parabola. So now the first thing that I want to tell you is this might bother some students. This is called the functional notation, and it simply says that this is a function, this one is named f. We just named it f. You could have a g of x, an m of x, a p of x, okay? And this simply means the f is what we named this equation, okay? And the x inside simply says this f equation is going to have x's in it. That's all this functional notation means. So we also know, which makes things easier, is that our functional notation can also be interpreted as y. You see? So now what we're going to do is find the coordinates. You know that if this is on a graph, it has to have an x and a y coordinate, right? It has to have an x and a y. So we're going to be finding 2 answers when we find our vertex. The first one we found out is to find the x part, and you do this first. To find the x part, you will take negative b over 2a. Negative b over 2a. Now this is something that you need to memorize because I don't think it's on your formula chart. Okay? Now where do the a, b, c's come from? They come from the coefficients of the x's. Okay? The first thing that you need to make sure is that your x's are in order according to the largest exponent, the next largest exponent, which is an invisible 1, and actually this is an x to the 0, which is invisible also, okay? So your exponents are in descending order, 2, 1, and 0. So this is good. This is good. So when they are in descending order, then the coefficient that is on the leading coefficient, the first one, is your A. Not including the x, just the number and its sign. So A, we're going to say right here, A equals a -4. So the next one and its sign will be your B, always. So B is 6, a +6. And C, probably you won't see this x0, x to the 0. This is our constant. It's the one that usually doesn't show an x with it at all. This is your C. They go in order, so it's pretty easy to find all of these values. So your C equals a +18. Okay? Now that's where these ABCs come from. Okay? This is a little review. Okay. And so to find the x of the vertex, we're going to take a negative because that's in our formula. And then we find out what is B. B is 6 over 2 times a -4. So x equals -6 over -8. If we simplify this, the negatives cancel, and we simplify 6 over 8 by dividing by 2, and we get 3/4. So x equals 3/4. So on our vertex, it's 3/4. I'm going to make this bigger. Vertex is 3/4. That's our x. And we still have to have a y value, okay? We still need a y value. So to give me more room, I'm going to erase this much. To find the y value, we simply plug in the x that we have. So now we have, I'm using the original equation now. We have y equals -4, and then where the x's are, we plug in. Use parentheses to plug in. I plugged in 3/4 for x, and it's squared, plus 6, plugging in 3/4, plus 18. And using your calculator from here, we simply do the math. So you always, using the order of operations, you always do the squared first and then multiply, okay? And I'm assuming you're using your calculator, so I think this is a -9 when we're done. This comes to 9, nope. This comes to 9/16 times -4 over 1 plus this one will be 18 over 4, but if we simplify 18 over 4, we're going to come with 9 over 2 plus 18. So now we have -9/4 plus 9/2 plus 18. If we put that in our calculator, let me see. So we have, this becomes 9/4, a positive 9/4, I think. Yes. Plus 18/1, using your calculator here. I don't know, 4, 32, 72, 81/4. Is that right?
Yeah.
Yes.
Is that what y'all got?
Yeah.
81/4?
Yes.
Okay, good. Sure enough. 81/4. Now, these are the coordinates, the X and the Y, of the vertex, okay? But when they ask you about the max or the min, they're only wanting the Y value. So this whole thing, this point is where the vertex is of this parabola. But if they're wanting not just the vertex, but they're wanting the maximum value, they're wanting the highest value, well, that's the Y-axis. So they want the highest value, and that will be the Y coordinate. Okay? Are we all right with that? Okay. So the next paper, this was a review from yesterday. And the next paper, I didn't go over it in the video so much yesterday. We've done vertex. It's evaluating an equation given a specific value. So this is on a worksheet that I sent to you yesterday. And here's the number 1 off of that worksheet. I think you guys already know how to do this. It says, the instructions say, evaluate each function at the specified value. And what this problem looks like, number 1 says f of x equals x plus 3 squared is 2x squared. And then it has a semicolon. The semicolon is not mathematical. Equals -12. So what they're saying here is, I want you to find out what the value of this is if you plug in -12 for x. You see? So let's do this. We know that f of x can be translated as a y. And so now we have y equals -12 plus 3 squared minus 2, and we need to put this in parentheses, so we've got -12 squared. Everybody okay? So please excuse my dear Aunt Sally, we need to do parentheses first. So this doesn't count as a parentheses because it only has one value in it. It's just for emphasis. This one is a parentheses because it has something to do inside. So what we're going to do is figure this one out first. So we have y equals -9, -9 squared minus 2 times negative 12 squared. So far, so good? Okay, the please excuse my dear Aunt Sally. We've taken care of parentheses. The E stands for exponents. So in the next step, we're going to square this and square just this part, not the 2. Okay, so now we have, where is my chalk? Okay. Y equals, anything squared is positive. Yes, I hear 81 minus 2 times
144.
144. And again, anything squared is going to be a positive. Okay, next step. We've done all of the exponents. Now it says do all the multiply and divide left to right. So if we start here, we have a minus. We're not supposed to do the multiply. So we're going to multiply here. We have y equals 81 minus 288. And then we've done all the multiply and divide, do add and subtract. The first ones we come to left and right. And this is going to be 209 negative, right? Negative
207 positive.
7. Thank you.
Oh, negative, yeah.
Negative 207. So to evaluate this equation here, given this value, the only thing you have to do is plug that value in everywhere, not the here, because that's just a title. You plug it in everywhere there's an X. Okay? Plug it in with parentheses. Very important. Because if you're one of those that just uses the calculator all the way through, and you did not put this negative 12 in parentheses, you might, first of all, think that it's 2 minus 12, or you would just put, instead of the parentheses, you would just put negative 12 squared, and you would actually give the wrong answer in the calculator. So it's very important to plug in your values of X using parentheses, especially if you're a calculator person. Okay? So this is all you're doing on that other sheet. Okay? Now to the new stuff. We're going to be finding X and Y intercepts of that same parabola. We're going to be finding out what they are. Okay, let's get an equation. There's an X and Y intercept somewhere. Well. I don't know where my paper went. Excuse me 1 second. There they are. All right. Here's our equation. The instructions say, find the x-intercept and the y-intercept of each quadratic function. Okay? This is a function because it has functional notation. We can also call it an equation. X squared plus 9x plus 18. Now what we're going to find here, we're going to review finding the vertex, but we'll do that last. And then we're going to,
Do we have those papers?
you don't yet. So, but this is number one if you want to take notes. Okay.
We can't see
We're
it.
gonna find the y-intercept first.
It's too high. We can't see it.
Okay. Thank you. We're gonna find the y-intercept, and then we're gonna find the x-intercept. And notice that I put an S on here because it's a possibility that we will have multiple x-intercepts. Okay? Now we know that the vertex is a point that is going to have an x and a y. Our y-intercept, if you'll remember from our past videos, that intercepts are points that have 0 somewhere in it. Intercepts always have a 0. So this will help you if you'll memorize this and write it down before you start your work. It will help a whole lot. Now, if we're trying to find the y-intercept, we're trying to find this number right here in the y. If we're trying to find a number in the y, then the other one is a 0. So this is what our y-intercept is going to look like, and you'll understand why we write this first. X-intercepts, possibility of 2 of them, means that we're going to try to find an x value, which means we need this number and possibly another number. So that means that the y is going to be a 0. This is important to write that down first because it keeps you from skipping steps or forgetting to do something. Okay, we're going to find the y. We're going to wait till the vertex to the end, only because we just did it. Okay, the y-intercept. This is how you find the y-intercept. You look up here and you say, oh, I need to plug in 0 for every x. Okay, so we know we have y equals, and I'm going to plug in 0 for every x. So I have 0 squared plus 9 times 0 plus 18. So my y, which is the number I'm looking for, equals 0 plus 0 plus 18. And so my y value is going to be 18. That is my y-intercept. Now, the x-intercept is a little more complicated because we're going to have to find the x values. And if we're going to find the x values, if we're going to find the x-intercepts, that means we want an x number. So we're going to put a 0 wherever the y is. Remember that this is y. So now we have 0 equals x squared plus 9x plus 18. And this takes us to solving equations. There are 3 ways to solve a quadratic. Okay, you can actually look at a graph. Okay, if they give you a picture of a graph, you can solve a quadratic. You can do what they call factoring, which is pretty easy. But for the GED test, I'm going to teach you the third one because the factoring doesn't always work, but this always does. The quadratic formula. Now, the quadratic formula is actually on your formula chart. It looks crazy bad when I put it on the chalkboard for the first time. Okay? Go ahead and show her where it is. Now, before we start into the process, I want to make sure that you understand what solving the quadratic means. It means we're finding the x-intercepts. That's what solving a quadratic means. We're finding the x-intercepts. But sometimes they won't say solve the quadratic. They won't even say find the x-intercepts. They will say find all the zeros. They call the x-intercepts zeros. And I think it's because the zeros are in, I guess. Okay. So I am going to teach you the quadratic formula, and that's going to be our main focus today. But I need to talk to you about the factoring. I'm not going to teach you how to factor, but there are questions on the test, I think, that show you a quadratic that's already been factored. And if they do that, then you can find out what the answers are easily. And you're going to have a paper on this today. So I'm going to factor this. You don't have to, okay? But I want to show you what it's like after we factor it. It will be two sets of parentheses, which are called binomials, and they're multiplied together. This will be 6, 3. Okay, this is a factored quadratic. They took the quadratic and they factored, and if any of you want to know how to do this, I don't mind teaching you, but I'm not going to stop and do that because the quadratic formula works all the time. But you do see questions where it says, here is, tell me what the zeros are, or tell me what the answers are, or solve this quadratic, blah, blah, blah. And they give you this part where you don't have to do the factoring. The way that you do this is, think about this. If you have, in my hand, I have a mystery number here. And in my hand, I have a mystery number here, okay? And I'm gonna multiply those two mystery numbers together, and I'm gonna get 0, okay? Now tell me about these mystery numbers. If I multiply this mystery number in this hand to this one, and I get 0, what do I know about these numbers? One of them has to be 0, correct? Could both of them be 0? 0 times 0? Yes, both of them could be 0. So what we're going to do is separate these and say x plus 6 could be 0, or x plus 3 could be 0, or both of them could be true, correct? So the whole idea is I'm trying to find the x's. So let's solve this. We're going to solve them separately. And you all know how to do this. If I want to solve for the x, I'm going to subtract 6, and now have x equals -6. Okay, this is one of the zeros. -3 here, -3. So x equals a -3. Those are the x-intercepts, and they go right here. Got a -6 and a -3. Y'all see? Okay. So if you're already given a factored equation or a factored quadratic, then all you have to do is take the pieces, set them to 0, and solve for x. Okay? What if you're not given those? Then that's where we go to the quadratic formula to find the x. If you don't have a factored equation, then you're going to use the quadratic formula to find the answers. So here we go. This is the last part. Of course, we'll do the vertex in a minute, but this is the last new part for today, so hold on tight, okay? And don't cry when you first see it. Okay. X equals -b plus or minus the square root of b, put that b in parentheses, squared minus 4ac, all of it over 2a. Okay, this is the quadratic formula that we're going to use to find x, because we want x's to go in the x-intercepts, right? Okay, now again, the ABCs are going to come from the same place that we got them just a little bit ago. So the A is the coefficient on the x squared. What is the coefficient on the x squared?
Y.
1, okay? So A is 1, a positive 1. And what is B? 9. It's a positive. Let's make sure and put our signs so you recognize the negatives when they come, okay? And C will be a positive 18. These are the numbers that we're going to use to solve this quadratic formula. Let me get a different color, it'll help. Hopefully.
Y is 1.
Are you guys still okay?
Yep.
Yes, ma'am.
Right. Okay. So this is the formula we're going to use. I like to start low and take care of all of this first. That's the So here's my step. Okay. X equals, now I'm just copying and filling in the letters. So I see a negative in the problem. I have to put a negative before I start the problem. And then I go find out what B is, which is 9. -9
-1.
plus or minus, I'm
-9.
copying, square root of, and we said to put the B in parentheses, it's a 9, squared minus 4 times whatever A is. A is 1. C is 18. And don't forget to put that all over. It comes back to the equal sign. All over 2 times whatever A is. Can y'all see that lime green color? Can you see it okay?
Yeah.
Not that good?
I can see it.
Okay. I am going to pull this down so we can see the rest. Get out. Get rid of some of this. So now that I have numbers in here, all I have to do is figure out what this is. Now, it's perfectly fine if you want to write this on one line, then go to the next line and do a little bit, and the next line and the next line. I used to do that and use up a whole sheet of paper for one problem. And I decided that I like to take a shortcut, and I know my class likes shortcuts. So I look at this whole equation, and the one that looks the scariest is this square root thing. So what we're going to do is work on that square root thing first. 9 times 9, 9 squared, 81. And I'm going to write down the minus. And then I'm going to multiply 4 times 1 times 18, which should give me 72. Now, all I've done is the math underneath the radical, but I haven't done anything with the square root radical yet. So it still has a square root radical on top. Then I find out what 81 minus 72 is, and that's 9. But again, I only did the math underneath, so I still have a square root radical. And then on my calculator, I'm going to find out what is the square root of 9. And I found out that it's 3. Okay, so that's the top of my little mountain, and I've taken care of all of this. So now what I'm going to do is just write this problem again. Let's go over here. So I'm going to write the problem again so it doesn't have all this stuff in it. So now I have x equals, and I'll let you look at it in a minute. I'll get out of the way. 9, or negative 9, plus or minus 3 over 2. Y'all see? I took x equals negative 9 plus or minus, and now all of that stuff came out to be 3, so it makes the problem look so much better. Y'all see? Now, this thing we haven't dealt with much. It says plus or minus, so that means there are 2 answers to this. This is the place that you split this into 2 answers. We're going to say x equals negative 9 plus 3 over 2. We did the plus part. And now we're going to say x equals negative 9 minus the 3 over 2. And when we solve this, we're going to have a negative 6 over 2, which equals a negative 3. Here's our negative 3. That's where we put it because x equals that. And then here is a negative 12 over 2, which becomes a negative 6. Here's our negative 6. So whether you do it from the factored part and set those equal to 0, or whether you use the quadratic formula, you're going to get the same answer. And usually a quadratic, not all the time, but usually a quadratic will have 2 answers. A lot of the times it will. Okay? We said 2 answers, 1 answer, or 0 answers, right? Okay, so now we have our x-intercepts, we have our y-intercept. Let's go back and review the vertex one more time. And then using just those points, we can actually graph our quadratic, our parabola. So anybody need this work anymore? You okay, Isabel? Josh?
Yes, ma'am.
Okay.
Yeah, I got it.
Okay, I'm erasing this part because we found our x-intercepts. Now we need to find our vertex. It looks like a lot, but when you start doing it, it's really not. Okay, so we look at our equation right here, our quadratic, and we see that the beginning is a positive. So we know that we're going to have a parabola. We know that our parabola is going to point up because the beginning coefficient is positive. So this is what it looks like, and we're going to be finding this. We want to find the vertex. And this will help you all a lot if you want to know. This is probably the farthest with quadratics we're going to go. So we're going to practice on it another couple of days, okay? But we're not going to tell you a whole bunch of other stuff, okay? All right, so we're going to find the vertex. And we found out for the vertex, to find the x part, it's a negative b over 2a. Now, when you work on this worksheet, finding the vertex, make sure that you write this equation over and over again so you will remember it because it's not on your formula chart. Okay, so to find the x part of the vertex, we're going to use negative b over 2a. It's the same ABCs. So I have a negative, and then whatever b is, over 2 times whatever a is. So my x of the vertex is negative 9/2. Are we okay? So up here in the vertex, negative 9/2 is our x part. When we find the x part, we can go straight to the original problem and plug in our x's. Here's our original. So we have y equals x. Remember to use your parentheses. This is our x, and it says to square it, plus 9 times a negative 9 over 2 plus 18. Okay? So neither one of these are the definition of the parentheses that we use in PEMDAS. So the next step is the exponent. So we're going to do the exponent, and we get 81/4. Because when you square a fraction, you square the top and you square the bottom, and it will always be positive. And now I'm going to multiply, and I get negative 81/2, because this is the same as 9/1, so I multiply the top and the bottom, plus 18. We're finding out y, so now all you need is your calculator or find common denominators if you do this by hand. So y equals, did you get it already?
No, I don't have it back here.
Oh, okay, and I didn't get them out. Okay, I thought you said the answer. 81/4 minus, because of plus and a negative. So this will be 162/4, because I multiplied both by 2 so I could get common denominators. Plus, and I'm going to multiply by 4 because I want common denominators. This is doing it by hand. You can do this in the calculator. And so I have 72/4. So are we okay? Okay. And so when you subtract this, you're going to get a negative 81/4 plus 72/4, which equals a negative 9/4. Okay? And so the vertex is going to be at a negative 9/4. You'll see? That's the vertex point. Now, since we figured out the vertex, we figured out the y-intercept, we figured out the x-intercepts, now we can actually graph this equation. And I'm just going to estimate. So let's graph this. X, Y. Okay, let's do the easy ones first. Let's do all the intercepts because the vertex is going to be fractions. So the y-intercept is going to be on the y. So you start at 0 and you don't go any left or right and you go up 18. So I'm going to assume 18. Yeah. I was thinking it wasn't going to be right. Let's assume that's 18. I'm just getting close. Okay, 0, 18. Then I have the x-intercepts. There's one at 1, 2, 3, 0, negative 3. And another one here. Okay, so far that doesn't look like much. Looks weird. But now let's put the vertex in. So if the vertex is negative 9/2 and negative 9/4, the easiest way to graph these is to change this into a mixed fraction or a decimal. And you're going to get like negative 4.5 and negative 2.25, I think. Let's see, 4 into there is 1 and 1/4, yes. Okay, so let's find that point. So if that was 3 and that was 6, then we're going to go negative 4.5 right here, and then down 1, 2, 3. So 2.5 is going to be about right here. Does it make more sense now? Does the parabola make more sense? It's going to be pointed up, and the vertex is going to be the bottom part. So make sure that you make the bottom part a curve. Don't make it a V. That's a different kind of graph. The parabola has a curved bottom, and it will go up through here and up through here. Ta-da. If you can find the x-intercepts, the y-intercepts, and the vertex, you can graph an equation. I know this is a lot of information, but if I keep talking, your heads are going to spin, and we've already been working at it an hour. So what I want you to do is try the worksheets today, and you'll have the time here in class to ask questions. We'll go over it again tomorrow. Okay, does that sound good? All right. How about y'all? Isabel, Josh?
Yeah.
Yeah, sounds
You ready
good.
to try? Okay, your
All right.
papers will be coming in the email. Okay?
Okay.
Okay.
You know I love you.
Love you too.
Okay.
Me too.
Okay, I'll see you tomorrow.